This is day 22 of Advent of Code 2024 Done in Go, and this challenge is called Monkey Market. As you're all teleported deep into the jungle, a monkey steals the historian's device. You'll need to get it back while the historians are looking for the chief. The monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. Your only option is to buy bananas on the monkey exchange market. You aren't sure how the monkey exchange market works, but one of the historians senses trouble and comes over to help. Apparently, they've been studying these monkeys for a while and have deciphered their secrets. Today, the market is full of monkeys buying good hiding spots. Fortunately, because of the time you recently spent in the jungle, you know lots of good hiding spots you can sell. If you sell enough hiding spots, you should be able to get enough bananas to buy the device back. On the market, the buyers seem to use random prices, but the prices are actually only pseudo-random. If you know the secret of how they pick their prices, you can wait for the perfect time to sell. The part about secrets is literal, the historian explains. Each buyer produces a pseudo-random sequence of secret numbers, where each secret is derived from the previous. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. Calculate the result of multiplying the secret number by 64. Then mix this result into the secret number. Finally, prune the secret number. Calculate the result of dividing the secret number by 32, round the result down to the nearest integer, then mix this result into the secret number. Finally, prune the secret number. Calculate the result of multiplying the secret number by 2048, then mix the result into the secret number. Finally, prune the secret number. Each step of the above process involves mixing and pruning. To mix a value into the secret number, calculate the bitwise XOR of the given value and the secret number. Then the secret number becomes the result of that operation. If the secret number is 42, and you were to mix 15 into the secret number would become 37. To prune the secret number, calculate the value of the secret number modulo 167777216. Then, the secret number becomes the result of that operation. If the secret number is this one, and you were to prune it, the secret number would become this. After this process completes, the buyer is left with the next secret number in the sequence. The buyer can repeat this process as many times as necessary to produce more secret numbers. So if a buyer had a secret number of 123, that buyer's next 10 secret numbers would be like this. Each buyer uses their own secret number when choosing their price, so it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number of each buyer, the puzzle input. So for example, if it starts off with 1, 10, 100, and then 20, 24, this list describes the initial secret number of 4 different secret hiding spot buyers on the monkey exchange market. If you can simulate secret numbers from each buyer, you'll be able to predict all of their future prices. In a single day, buyers each have time to generate 2,000 new secret numbers. In this example, for each buyer, the initial secret number and the 2,000th new secret number they would generate are this. So it starts off with 1, goes to this number, starts off here, then goes to here, after. So, the 2000th one is this. Okay, so adding up the 2000th new secret number for each buyer produces this. What is the sum of the 2000th? Okay, that sounds pretty interesting, so let's get started. First thing we'll do, we will copy the instructions into here. So let's grab this. We'll put it up at top here, and then we will grab the mix and prune. So something I noticed straight away, 64, 32, 2048, these are all base 2 numbers, so that will make things easier. We can do bitwise calculations instead of actually using those numbers. And just talking about XOR, which we did in the previous one, so actually let's read it again. So calculate the final. So you multiply, then mix, then prune. So mix is XOR. So first you have your secret, you bitwise it, you then XOR it with the previous number. Then you prune it. So, right, I'm just going to run it so I can get my input. Okay, so I've now got my input file. Okay, that's quite a large list of numbers, but that's fine. But we've got our lines. We can then do for line. Actually, first output goes up here for line in range lines, then secret. This would be equals strings.toy. Oh no, not strings. String conv.toy and line. So we've got our secret, and we have to do this 2,000 times. So each number 2,000 times. So we'll do for I equals 0, I less than 2,000, and I plus plus. Now it's for the actual what we're doing here. So I'm just gonna put that into here. So calculate the result of multiplying the secret number by 64. So that is secret, then bitwise to the left, and so 2, 4, 8, 16, 32, 64. So bitwise 6, and then we then mix this result into the secret number. So that's XOR, and that was caret equals. So bitwise multiply, oh I guess bitwise shift or multiply by 64. Then we're XORing it with itself. We got this, and now we need to do the modulo. So I feel like it's going to continue with the theme of base 2. So let's try see if that is a base 2 number. So let's do 2 times 2, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so that's 24 bits. And okay, so this would be another bit operation. Okay, so this is a modulo. I don't know, let's look up Golang modulo bitwise. Let's see this Reddit post, modulo Golang. Okay, so there's percent, or no, that's not what I'm after. That's just normal modulo. Maybe this, go bitwise operations. I guess we could just do modulus, but considering we're doing 2,000 operations over all these numbers, so 2,000 things 2,000 times, I guess it's actually 6 instructions or 9 instructions, whatever it is, 2,000 times. Like I want to, like, it's obviously going to be a performance issue with this, so that's why I am looking into it. How to find modulo using bitwise. Programming Golang. No, I guess I'll just do normal modulus. If it does become an issue, we can figure that out later. So then it'll be secret. Is it the remaining? Okay, so it's what modulus equals this number. So we do that for the first. Then now we are dividing, so it'll be this direction and 32, which is 1 less than 6, so that. And now we do this. And it's multiplying 2048, which is 11. So we do all this. Then we have our secret number. Then will be output plus equals secret. And I think that's all we need to do. But let's grab the test input right here, so you can verify if it works. Let's do that. 3732763. That is correct. So now let's switch to the actual input and see if it will work. Okay, cool. Good to know that normal modulus wasn't a performance issue, but maybe in part 2 it will be. So let's submit that. And that was correct, so on to part 2. Of course, the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyer offers are just the ones digit of each of their secret numbers. So if a buyer starts with a secret number of 123, that buyer's first 10 prices would be okay, so 306, the very last number. This price is the number of bananas that buyer is offering in exchange for your information about a new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little, but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Unfortunately, the monkey only knows how to decide when to sell by looking at the changes in prices. Specifically, the monkey will only look for a specific sequence of 4 consecutive changes in price, then immediately sell when it sees that sequence. So if a buyer starts with the secret number of 123, that buyer's first 10 secret numbers, prices, and the associated changes would be this. Note that the first price has no associated change because there was no previous price to compare with. In this short example, within just 3 first few changes, the highest price will be 6, so it would be nice to give the monkey instructions that would make it sell at that time. The first 6 occurs after only 2 changes, so there's no way to instruct the monkey to sell then, but the second 6 occurs after the changes -1, -1, 0, 2. So if you give the monkey that sequence of changes, it would wait until the first time it sees that sequence and then immediately sell your hiding spot information at the current price. winning you 6 bananas. Okay. Each buyer only wants to buy one hiding spot. So after the hiding spot is sold, the monkey will move on to the next buyer. If the monkey never hears that sequence of price changes from a buyer, the monkey will never sell, and will instead just move on to the next buyer. Worse, you can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. You're going to need as many bananas as possible, so you'll need to determine which sequence of 4 price changes will cause the monkey to get you the most bananas overall. Each buyer is going to generate 2,000 secret numbers after their initial secret number. So for each buyer you'll have 2,000 price changes in which a sequence can occur. So for this, there are many sequences of 4 price changes you could tell the monkey, but for these 4 buyers, the sequence that will get you the most bananas is this. Using that sequence, the monkey will make the following sales. For the buyer with an initial secret number of 1, it does that on the first occurrence of 7. Buyer 2, first occurrence is 7. Buyer with 3, it does not occur. And for this one, the price is 9. So by asking the monkey to sell, the first time each buyer's price goes down 2, then up 1, then down 1, then up 3, you get 23 bananas. Figure out the best sequence to tell the monkey so that by looking for that same sequence of changes in every buyer's future prices, get the most bananas in total. Okay, interesting. So let's remove this for now. So we are able to just directly copy this into part 2, but now we're going to need to keep track of the different possible sequence of numbers and what the following number after that would be. So when we're running this, we'll need to look at the previous 4. Okay, so let's do if I is let's see, greater equal to 3. We'll do sequence is equal to, okay, no, we can't do that. We need to keep track. So in this line, let's do secrets is equal to I guess this list of events. I guess make it of length 2000. So when would we add it to this? So we'll do secrets equals append secret. Then we do the exact same thing down here. Actually, maybe we should be doing this up above. Okay, trying to think. So we need to keep record of the secrets. We need to go through, grab the very last number in it. And we're going to put this back into here, but we will keep track of what we'll call a secret diff. This will be map of the 4 int differences, and it will return a number. We will do the exact same thing in here, current secret diff, and we will do what we add secrets. Now if I is greater than 3, greater equal to 3, so we want 0, 1, 2, 3, let's do n1 is equal to secrets I minus 3, then modulus 10 to grab the last number within it, and we do the exact same thing. So 2, 3, 4, 3, 2, 1, 0, modulus 10. We then do, okay, so we need to get the difference between each of these numbers. Okay, so we'll need to do if I equals 3. Well, first we do first num. This is equal to, let's make it -1 just for now. If I equals 3, no, we start at 0. If I is greater than 3, first num is equal to this, but minus 4. So we have the first number. We then do diff is equal to 4 int, and this will contain n1 minus first num. Is that how we want it? So if we start on a 6 and this is a 3, that would make the number -3. So that is the current difference. So that is correct. And then we essentially just do this all, and it'll be n1, n2, 3, 4, n2, and 3. So we have this. Is it the n4 one, which is the number of bananas? Okay, so yeah, n4 is the number of bananas, and it's the first time that sequence appears. So, it defaults to 0 within the map, so I can't just use that. So I might need to create another one. Exist bool. So we would have to do if not diff current secret diff is equal to n4. Am I using first num here? Yes, I am. Okay, I did it. There we go. So we're doing that for each individual one. I now need to handle secret diff. Okay, no, I don't need this one. I just need to use that one. So we then go to here and do plus equals. And what's the output we're doing? What is the most bananas you can get? Turns out I'm doing all my code in part 1. So let me just switch all of this over. So we will use the test input and let's put a breakpoint there. Do I have secret diff? Yep. Okay, so that's not working. Or did I... Okay, I need to put the breakpoint further. I need to rerun it. Okay, well, I can't put it on the bracket, so let's go further down. Secret diff. Okay, so that's not working. Cool. Something I did forget is then equal true. Although, why isn't that condition working? So we've got secret diff. And what is diff? Did I create that correctly? It's all zeros. Okay, I guess, what are these numbers? Okay, why are you... Am I not adding to secrets? Okay, I was doing append, not instead of this. No, secrets. I is equal to secret. There we go. So now hopefully that would work. Secret diff, that appears to have worked. It's got 7,000, which might be fine. Let's go to here. Well, actually, let's find the example given here. Watch secret diff for int this number and see if that works. Okay, that doesn't work. We will test is equal to for int this, and we can do format dot print line secret diff test. That has 16. Now let's try something else. We'll bring this to the top. Let's do if inside of it, if diff is equal to test print format dot print line int 4. Okay, apparently only 7 and 6 for that, or 7 and 9. So my condition might be wrong because okay, we'll print that and then we'll print. I was going to type secret initial secret is equal to secret. And then we will print out the initial secret just so we can see what's going on. So 1 and 2024 is working, but it's not working for this one. So my condition might be wrong. So secret number 2, that would be 10. Oh wait, it's using these numbers, 1, 2, 3. Okay, yep, well that's working. 23, that's what it was, right? Cool. Let's remove all the extra stuff I added, which we no longer need. And what we need now is to sort through this for the highest number. So we get rid of output secret. Let's do for underscore value in range secret diff if value greater than output is equal to value 23. So let's now switch to the real input and see how this goes. 2121. So let's submit that, and we got the correct answer. So if you like this video, make sure to like and subscribe.